right, today we're going to start off by talking about domain and range. So domain is all the possible x values. So remember the x-axis goes left and right that your function uses or touches. Range is all the possible y values, the y-axis goes up and down, that your function uses. So a handy thing about domain and range, if I was going to write it out, D comes before R in the alphabet, D for domain, R for range. Well, luckily X comes before Y in the alphabet, so if you ever panic and don't remember, that can help you partner them up. D goes with X, and R goes with Y. Domain is for X and range is for Y. So one of the things we're going to do is use interval notation to help us answer domain and range questions. One thing you need to know for interval notation is you always go smallest to largest. No matter what you're doing, you always start with the smallest number and end with your largest number. There's lots of little puzzle pieces I have to teach you along the way, and then we'll put it together down below. But if the endpoint is not included, one way to see an endpoint is not included is if it's a hollow point, or if it's an arrow, it goes to infinity. Infinity, there we go. Then you'll know you're going to use, plus or minus infinity, I should say. Then you'll know you're going to use a parenthesis, the curved ones. If the endpoint is included, then you use, that one's called a bracket. The square ones are called brackets. You're going to use that if it's a solid point. The next one, which is really hard to draw, that's called a brace. That's used only if it's a scatter plot. Only if it's a bunch of random, discrete dots, then you know you're going to use braces. That's the infinity symbol, just so you know what it looks like. And the computer doesn't have an all real number symbol, but what you do is you draw two legs and then make an R out of it. That's the all real number symbol. It's a real quick way to say from negative infinity to positive infinity. It's just quicker and easier to write, but either one of those answers would be fine if it was the correct answer. You might have been doing inequalities in previous courses. We can also answer domain and range in inequality notation. You start with the left, and then you want to use less than, and then X is in the middle, and then the next less than. If it's not included, I should make those colors match. So let's go orange. You use these symbols if they're not included. Remember, not included is up here, the hollow points or arrows, infinity. You use the other symbol, let's go green, less than or equal to, greater or equal to, if they are included. Remember, are included is our solid points. So these are just going to be easier if we just jump right into the answers, not the answers, the examples. So down below on your page, on my next slide, here's our examples. So domain and range is like a fence around your graph. So looking at my first example, if I wanted to draw a fence, let's do X. If I look at the X-axis, domain is the X-axis, right? How far left, what's the furthest left you can go and draw a line that your graph touches but doesn't go past? So what I'm saying is, if I draw a line right here, I go through the solid dot at -3, the graph touches it, but there's nothing over here, right? There's no graph on that side. So I've fenced off the left. So for my domain, I guess I'll just stick with yellow. I drew a line, a fence at -3. I knew I drew it right through the dot, but I talked about it when we went through, and hopefully you can see it on your paper. It was a solid dot, which means it's included, so I use a bracket. So this is saying the furthest left my graph goes is -3, and it's a solid dot at -3. Then you write a comma. This is for interval notation, by the way. Then it touches everything until, what's the farthest right? It's always from left to right. What's the farthest right your graph goes? Well, I can draw a line and cut the graph off right here at 6. It goes through the graph at a solid point, but there's nothing over here. So it goes to 6, everything from -3 to 6. And it was a solid point, so I'm going to use a bracket. This would be the answer to domain in interval notation. For those of you that love inequality notation, same idea, same picture, same everything. -3, because it touches it, you use less than or equal to. Domain is the x variable. Less than or equal to 6. Both of these mean the x's are from -3 to +6, including -3 and +6. So we fenced off the x-axis. Range is the y-axis. Let's work on fencing that off. Bottom to top, smallest to largest. Lowest your graph goes. I see there's a dot at -3. I know, again, I drew a line right through it, but it was a solid dot. So the smallest it goes is -3. I'm sorry. I'm looking at the y-axis, right? What's the y value at that point? The y value at that point is 0. Since it was a solid dot, it's a bracket because it does touch 0. Comma, to imply it hits everything else until it gets to, what's the highest your graph goes? Remember, I drew that line. There's no graph down here. Where can you draw a line up above so there's no graph above it? So we probably set this up because we wanted you to draw a line right here, because that's the end point. But look, there's still graph up above there. So you have to go all the way to the end of your graph. It's not always an end point. The highest my graph goes is right here. And it actually touches your graph, but there's nothing above that line, right? The y value there is 4. Is it included or not included? Is that a solid point or a hollow point? Remember, any point on your line, unless you literally see a big hollow dot, it's assumed that it's a solid dot. So that is included, so it's bracket 4. If you love inequality notation, which, to be honest, we don't use inequality notation in the upper levels. We want you to get used to interval, but it's perfectly fine if you want to keep using inequality. The lowest it goes is 0. It touches 0, so less than or equal to, let me erase this dot. 0, less than or equal to. But now you have to remember range is the y values, less than or equal to 4. Those are the 2 different ways you can answer this. Please don't give us both ways on the test. I would just stick with interval notation, because it's just less writing and less stuff I have to remember. But either of those answers would be fine. We're fencing in the graph. Okay, let's look at the next one. Where can you fence off the x's? Domain is x. So you might want to draw a line here, but this is an arrow. So that means, even though you don't see it right now, it's implied, because it's an arrow, that the graph keeps going. So if that graph keeps going to the left, I can't fence it off to the left. So that means it goes off towards -infinity. Numbers on the left are -infinity. If I try to fence off the right-hand side, you might think right here, but that has an arrow also. So that's going off to +infinity. So a few different ways we can answer this. Interval notation. You could do -infinity, +infinity. Infinity, you can't actually touch it. It's not included, so you always use parentheses on both of them. So that's a perfectly good answer in interval notation for domain. Remember, whenever that's the answer, you could also just write the fancy R, and that could be the only thing you write, and that could be your answer. So here's 2 answers that mean the same thing for domain. And then if you love interval notation, you could also do -infinity less than, because it's not included, x less than infinity. That's your 3rd way to write the same answer. You get to choose the way you like the best. What about the range? Those arrows are slowly going down and slowly going up, right? So same idea for range. I'm just going to go with my favorite, all real numbers. But you could do the same thing with the parentheses, -infinity to +infinity, parentheses. Or you could do the same inequality, but make sure you put a y in the middle of that. Same thing. Next, fence in your circle. I'm looking at the circle graph. What's the furthest left it goes? What's the furthest right it goes? See if you can answer domain. So fence, ask yourself, is that a solid dot or a hollow dot? Is that included or excluded? I'm going to stop doing these all the different ways. I prefer I don't know why I keep saying, interval notation, but you can do whatever you'd like. But it definitely goes from -1, it touches every x value until it hits 5. And any regular dot, when you draw a graph, when you draw anything, you are drawing with solid dots. So those are both brackets. Other options available, but I'm sticking with interval notation. Range, lowest it goes to the highest it goes. I have fenced in my graph. Everything is inside that little rectangle. Well, I guess technically it's a square, but lowest y value, -4. Highest y value, 2. Every dot is a solid dot, brackets. Hopefully you're catching on. Okay, now you finally see hollow dots. So if you were wondering, well, why does she keep doing brackets? That's what a hollow dot looks like. That's what a hollow dot looks like. Now we're going to have to pay more attention to whether it's included or excluded. If you don't see hollow dots like that, unless you see arrows, then it's always a solid dot, right? So domain, fence it off. Fence through a hollow dot. Fence through another hollow dot. Smallest x value to largest x value. Hollow dot is a parenthesis, hollow dot is a parenthesis. I need you to understand they don't always match, right? Maybe it's parentheses -3 and then bracket +3. So don't think that they always match. They could mix and match. You can mix and match parentheses and brackets. Same with inequalities, you could mix and match those. Fence in your y's. Lowest y through a hollow dot, highest y through a hollow dot. Smallest number first, biggest number, hollow dot, hollow dot. Hopefully this helps you understand domain and range. Okay, I added this one problem because I really want you guys to practice domain and range on your own and see if you really understand it. So this is on graph paper, so you can count out the tick marks. I didn't draw them, but it is on graph paper, so you can figure out where the points are. See if you can find the domain and range for this graph. Fence in this graph. So domain, x's left to right. Furthest left, fence it off through a hollow dot. Furthest right, fence it off through a solid dot. So we've got one of each. So furthest left, smallest x value first. That's -4. That one's going through hollow, parenthesis for hollow. Comma, it hits every x value until my fence on the right. My fence on the right is +3. That one's going through a solid dot, so that one's a bracket. So I wanted you to see that they could be mixed up, parentheses and brackets. There's no pattern to it. If you'd like to do inequality notation for this one, smallest number, not included hollow, is less than. The arrow always points the same way. All you need to remember is if it should have the equal to bar or not. If it's hollow, it doesn't touch it, so just less than. X for domain. And now this one is a solid dot, so less than or equal to. The arrow's still going the same way, but it has the equal to bar, and then 3. Those are my two options for domain. See if you can do range. Lowest through a hollow dot. That's at -3. Hollow dot is parentheses. What's the highest your graph goes? Your actual graph goes all the way up here to +3, comma, I forgot my comma. Any dot on the curve that's not actually hollow is a solid dot, so that's a bracket. If you want to see interval inequality, if they didn't both start with I's, I wouldn't be mixed up every time I talk. If you want to see inequality solutions, -3 doesn't touch it. Y less than or equal to, because it does touch 3. So hopefully that might have helped a little bit more. Okay, finally, fully describing a graph. All of these attributes we could ask you for on test day. What's the shape? So is it a line? Is it a parabola? Where's the line of symmetry? Does it open up or down? Does it have any asymptotes? If you don't know what an asymptote is yet, don't panic. We will talk about it later. The x and y intercepts, the domain and range, which is why I just reviewed that. Endpoints, the local min or max. Is it continuous? Is it just a continuous line, or is it discrete, meaning a bunch of random dots? And finally, is it a function, yes or no? So we are going to practice this on this page. So we are graphing and answering all these questions for x squared plus x minus 6. Hopefully you can look at this right away and answer what shape that is. You dealt with these a lot in integrated 2. X squared plus x minus 6, that would make a parabola. Okay, is it continuous or discrete? When you make your table or whatever you're going to do to graph this parabola, is it a bunch of random dots, or do you connect the dots? Right? We all know you connect the dots on a parabola, so it is continuous. Is it a function? Okay, let's answer all this other stuff after we graph it. So, options for graphing it, probably number one thing to fall back on is just make an XY table. So you want to plug in some x values, find the y values, and see what you get. So what, -2, -1, 0, 1, 2. If you'd like to have some space to do your math, maybe you don't write the y there. Maybe you write the equation there. We should all be able to get a graph of this. It might take us a little bit of time, but everyone's 100% capable of plugging in numbers and getting a sketch of this. So why don't you carefully fill in your table and plot your points. Pause your video. Okay, well, first of all, hopefully you wrote down the correct equation. I had it written down wrong in my table, but I did fix it. So these are the points I got, so I'm going to plot these points. -2, -4, -1, -6, 0, -6, 1, -4, 2, 0, and if I understand symmetry of parabolas, it must go through -3, 0 to be symmetric. And it is not random points, it is a connected parabola. Parabolas do not go flat at the bottom. We curve it down lower and back up through the matching points as best we can. This is my parabola. Is it a function? Remember, functions need to pass the vertical line test. If I imagine, don't draw these, an infinite number of vertical lines going through my parabola, does each one hit only once? No more than once? Yes, so it is a function. What way is the parabola opening? Up. You don't even know what asymptotes are. Let me just tell you it has none. You will learn about asymptotes this chapter. Line of symmetry. Okay. Line of symmetry is the line you can fold your graph on, and it folds perfectly and lands perfectly on top of itself. So straight through what? Straight through the vertex of the parabola would be my equation for my line of symmetry. So first thing we need to do is find the vertex. So I've got a bunch of points that line up nicely. My parabola is symmetrical, right? So I've got, these 2 points that are perfectly symmetric on either side of the vertex. The vertex must be in the middle of those. So if I've got a point at -1 and 0, add and divide by 2 to find the middle, -1/2. The line of symmetry is x equals, vertical lines, x equals -1/2. While we're at it, we need to find the y value of the vertex, right? So I've got this vertex answer blank down here, -1/2, comma. We need to plug it in to get the y value. So my equation is x squared, so -1/2 squared, plus x, -1/2, minus 6. If you carefully do that math, you get -6.25, or -6 1/4, or however you want to write it, as long as it's an equivalent answer. X-intercept showed up in the table, luckily enough. So there's one at negative 3, 0. I figured that one out by symmetry. And then there's one at 2, 0. Y-intercept also showed up in the table, but you should have been able to figure that one out real quickly. The y-intercept is the constant at the end of your equation. That negative 6 at the end is your y-intercept. And then go ahead and practice your domain and range. Can you fence this in? What's the domain and what's the range? So those arrows are going up and left and right forever. So since they're going left and right forever, the domain is all real numbers. But what about the range? What's the lowest value this graph touches? The lowest value is at the vertex. It's at negative 6.25. Does it touch it? Is it closed? Is it a bracket or a parentheses? It's a solid dot, so it's a bracket. How high up does this graph go? Well, it's got arrows at the end of it, so it goes off until infinity. Can you actually touch infinity? Nope, so that's a parenthesis. So bracket, negative 6.25, infinity, parenthesis. So hopefully this was helpful. Hope you guys are doing well.